Много се радвам, че днес сте тук заедно с нас. Не знам какво е времето на Марс, обаче навън е прекрасно. И преди да настъпи в София залеза, ще имаме възможност да чуем доклада на професор Ренц, както виждате от заглавието, за синьо-зелените залези на Марс. Сигурно ще бъде много интересно. Аз специално пък с особено нетърпение очаквам и тази част от неговия доклад, в която той ще ни разкаже за приложението на уреда, или устройството, което с негово участие е разработено за изследване на Марс, но има и приложение на Земята, но няма да казвам повече, за да има изненади. Много се радвам, че Австрийско посолство за поредна година е партньор на Софийския фестивал на науката и имаме възможност да приветстваме в София учен наистина от такъв висок световен ранг. Вашите аплодисменти за професор Ренц и очакваме с нетърпение неговия доклад.
So, yeah, welcome to the Mars. Yeah, I had the pleasure to work on this surface for many years. 15 years on the surface of planet Mars is quite a lot. Spending a lot of time with NASA and such things. So I will tell you a little bit of my experience. So some things which are really different. You see the Mars looks red. But in the sunset, it looks different. And I can tell you why. And then I will tell you some other things. This is the building where my office is in. It looks like a castle, and it was built like a castle in Hanover for the kings of the Welfen family, and they have been in a union with the British kings for 123 years, starting from 1714 till 1833. And after Queen Victoria, they decided to separate. After she came to power, they decided to have their own castle in Hanover. And after the Prussians destroyed that, they decided this is good for a university, so we are in there. This is only for the chemistry, but this is for the president of the university. You see, president likes a better one, and his office is actually here if you come by. And this horse, actually, maybe you have seen it in northern Italy, because some visitor from Italy used this as a symbol for his cars. Enzo Ferrari Institute I work with in Modena, but the Leibniz University is named after this gentleman, Gottfried Wilhelm Leibniz, and he has done something spectacular. For instance, he has written these things, these binary numbers. He has invented them. He said, to develop everything out of nothing, one is enough. He actually wrote this in Latin. 70% of his writings are in Latin, 20 in French, only less than 10 in German. All his writings are preserved in the Leibniz Library. It's a UNESCO World Heritage in Hanover. And why? Why did it survive, these 200,000 pages? Because he was so important for the king and for others. He knew so many secrets about the king that the king said, we have to protect everything which Leibniz has touched, otherwise the secrets will be spread. And we use, for our logo at the university, we use just this original handwriting, and this is the original letter as it still exists in Hanover, and we took this part as the logo of the university to honor this gentleman. If you don't know him for the invention of the binary numbers, this 1 is a 1, this 10 is a 2, these are our decadic number with 10 symbols. These binary numbers have only 2 symbols, a 0 and a 1. So this 1, 0, 0 in binary is equal to a 4 in the decadic numbers. So he developed the whole calculation method, and every computer, binary computer, works this way nowadays after his number system. But he also developed something like, if you know this integral sign, this integral for the infinitesimal calculus was invented by Leibniz in Hanover. Anyway, these are crystals. I like to produce such crystals. And if I shine light on these crystals, they change color. If I shine light on them, they change the color. Such kind of thing I love to do, and I do in my lab. And I can also change the color back, but I will ask you at the end of my presentation the following question, a chemical question. I love chemistry, but there is one element in chemistry which has the following two things. For this element is so wonderful, this element, that a huge artwork has been built by an artist which is taller than 100 meters, and a society has been founded with more than 100 million people. Really more than 100 million. I want to say much more than 100 million. And you can guess what is the answer, what is the element, what is the name of the artwork, and what is the name of the society. And at the end of my talk, I will come back to this. But before that, let me go to the Mars. We have heard some beautiful lecture today that the Earth takes 365 days to rotate one time around the sun. The Mars is different. The Mars takes double the days, 687 Earth days. And now there's a problem. One rotation around its own axis for the Earth takes 24 hours. But the same thing for the Mars takes 24 hours and 40 minutes. So when I work according to Mars time, a Martian day like this we call a sol, then if I start working today at midnight, then tomorrow I have to start at 0:40, the next day at 1:20, the next day at 2 a.m. Now, you understand, if you have a jet lag, you refresh this jet lag every day. So if you're tired, you stay tired. So when you work for a Mars mission, you always suffer a jet lag like this. That's why usually I had like 4 watches on each side, and then I was even tested by the medical guys to see whether I'm awake or asleep. Because most of the time, when I was inside the NASA control center, I didn't know whether I'm asleep or whether it's day or night outside. There was no window. I know only what is on the Martian day or night. So this is a little bit of a problem. But, by the way, if they are very close, like here, you can jump over from the Earth to the Mars in 7 months. But if you miss it, it takes more than 2 years, because it takes more than 2 years for the Mars to go around the Sun. Now, this is a picture from the first mission, successful landing on the planet Mars by NASA, the Viking 1 and 2 mission in 1976, and they thought the sky must be blue. They had only black and white cameras, but they took them through several filters and got a false color picture, and they assumed the sky must be blue. But this is the picture from 2005 with our rover. Here you see the solar panels and other things. It is red. Here, by the way, you see our device, but I will show you later about this. And now, the sunset. The sunset, it's going greenish blue. And the reason why this is the case is this is iron dust. And this iron dust gives you the red color. And when the light is not going through, it's passing by like this, then you see only the complementary color, which is greenish blue for red. On the Earth, it's just the other way around. And what's the difference? The difference is there is a lot of rain on Earth, so the atmosphere is washed out all these particles. But on the Mars, the pressure is too low. There's no rain on Mars. So these particles will always stay there. So we started on the 10th of June with these Delta II rockets from Boeing. And up here, there's the rover inside. You see, they started very well. We had 2 rovers, Spirit and Opportunity, and they started with a distance of 3 months. And they landed on the surface of planet Mars, and there were several missions. There was Viking 1, Viking 2. There was an ESA mission, the Beagle, which unfortunately was not successful, but it also had our device on board. There is the Opportunity and the Spirит in the Gustav crater. And this one is here, and that one is 180 degrees on the other side. So when this one goes to sleep, the other one starts waking up. So we had a chance to work for 24 hours without stopping. Maybe you like it or not, but it makes you definitely tired if you do so. And later on, there was the Curiosity and now the Perseverance rover here. So they are both very active. There's the Pathfinder from '97, which was used, which also has one of our devices, but it was in '97, and it was when you saw the movie with some Hollywood actors to rescue their life on the Mars. Some of them used this device. And yeah, it's nice to see that, that some real science is reused. And in one episode of the Big Bang Theory, they also used and captured our rover. If you know. Who knows the Big Bang Theory? Okay, oh, okay. Well, actually, I can tell you, in the movie, they are living in the Colorado Boulevard, right? But they, in the movie, in Pasadena, in the Colorado Boulevard, the Big Bang Theory, they have their, how would you say, their apartments. And I also lived there, but I, for real, they only in the movie. And then they go to the California Institute of Technology, to the physics department, and they do their job. You know, they are physicists, most of them. And they do it in the movie, and I do it in reality. So that's a difference. But it's fun to see. And this was a picture during the landing, so the landing rockets and the airbags, and this is a real picture, and we were extremely happy when this happened in the NASA Mission Control Center, that we could get this. And these are solar panels to get energy, and there is a sundial. What do you need a sundial for? This is a very old device. If you want to know, ask me these questions after my talk. And then we have found actually this, we landed in a little crater here with the Spirит, which has a diameter of 20 meters. And we found actually these minerals which we were looking for. And you can see these pictures from these minerals. And there was already some jarosite inside. And this jarosite was the proof that it can only grow in liquid water. But there is no water now. But maybe there was in the past. And indeed, we got a lot of evidence that in the past, the Mars had big areas of liquid water. So we can say it had some oceans. So the Mars was a blue planet, but no more. Now it's dry. And what happened? And can we avoid this for our Earth? And if we can find some answers to this question, then every euro we have invested up there is very valuable. And you see, the Opportunity rover was also traveling to the crater and the others. And actually here, after 90 days, the mission was scheduled for 90 days. And then our money did run out. And they said, 90 days, you're finished. But we need a Hollywood finish. So the finish was to drive into the crater and destroy the rover. We didn't like this as the scientists, but we were ordered to do so. But then NASA got short of money because they had to move some substantial amount of money from the science budget to the space shuttle mission after project, which is now SLS, which is now the Artemis mission, which should go to the moon soon. And we also are in this mission, the Artemis mission, and I hope we can land on the moon with them. But at that time, this saved our rovers because the NASA said, oh, Jesus, we have no money for the next missions now. The rover is still working and it costs us nothing. Why don't we keep the rovers alive? Unfortunately, we could still drive out of the crater, so we were already in, and I'm very lucky. I'm not allowed to tell every details on this, but at least we made it out. So this is the rover, and actually there are solar panels, and there is some antenna. This one can make direct contact to Earth. This one is actually an antenna which makes contact to some orbiter which circle around the Mars every 2 hours for they meet, and for 50 minutes they exchange data. And this is actually an antenna which goes directly to the direct to Earth with high data transmission, but it's a parabolic one, so you have to focus. It goes to the deep space network on Earth, which receives all this data. And that one is also sending the data to the deep space network on Earth. And here, this is actually the part, this is the device, the Mössbauer device, and this is the APX. With this one we can see elements, and with that one minerals containing iron. And you have a lot of cameras here, up there as well, some panorama camera, navigation camera, some infrared camera, and in the backside you also have them. And so here is the Mössbauer spectrometer, my most favorite one, and I'm the one responsible for this device now. So we develop this device for further missions, and we have made some improvements from the version which is seen here on the Mars. Yeah, and this is the second one built here. There was some microscopic imager and some rock aberration tool to clean the surface of the rover. So more or less you see them here again. This is a real picture from the Mars. There are some magnets to get some dust which contains iron. And here's the sundial, which I will come back later on. Now usually this device, now this Mössbauer is now handy, this size. But in my lab it looks like this size. So it's much bigger. So to miniaturize it, it's really some advantage. And this was done not by me, this was done by a whole group of people, starting from Professor Kankeleit, who was a colleague of Professor Mössbauer, who received the Nobel Prize for this Mössbauer spectroscopy. And he got it for his PhD thesis. Usually, you know, when you see a Nobel Prize winner, he is old, usually. Unless somebody has found something which is so important at a young age that you get immediately the Nobel Prize. And Professor Mössbauer got it for his PhD thesis. He has found something which has not been observed before, which mankind was looking for a long time. He found a direct proof of relativistic theory. With this device, you can prove relativistic theory. If I take a measurements and change a little bit the temperature, I get some relativistic corrections. And you don't need the speed of light or close to the speed of light in order to see these effects. No, because this is one of the most precise methods for mankind to measure things. You can measure it directly here and now. And that's why I like this Mössbauer spectroscopy very much. And that's why he got the Nobel Prize. Yeah, you see, it's handy, small and handy. This is me looking at the device. This is me looking at the rover at the NASA. This is actually Cape Canaveral. You can see it there. And here is the device mounted on this robotic arm in the NASA cleaning room. And this was the very first picture we took on the surface of planet Mars. For the first time, this was used on the soil of another planet. And the first stunning information was there is less corroded iron than this one. So this is an iron 2 silicate, which is like the green color of a green wine bottle. And the other one, this iron 3 is like, in a silicate, is like a brown beer bottle. So if you don't know how this color looks like, then look at the green wine bottle and the brown beer bottle, then you see how these colors of these minerals look like, this olivinium pyroxene. But you can find such minerals here in some magnetotactica bacteria. These bacteria, they have these magnets in there, and with these magnets they can control and they can do something. So when we know what iron is possible, like a green rust or a ferrihydride or the lepidocrocite, then we can tell you about the history. We can read these geological textbooks, and with this we can tell you about the future from the past. So we extrapolate to the future by reading these textbooks, which have been written over thousands of years, millions of years. And we found this is the signature, this is the signal for this jarosite, which I have been talking before, which is a sulfate with hydroxy groups and iron. And this only grows in liquid water because this OH is in. And so we found this one, and beside that, we saw a huge sulfur peak, which was unexpected, and this confirmed this one. So we had the second method with the APX to get this information. And we found some little berries on the surface of planet Mars. These little balls, where are these balls coming from? How they are created? And this is a very spectacular thing which has many answers. But they could be from some molten things or other parts. And if you have the iron, you can melt it, and then you have only iron and oxide. And you get maybe these berries. Or you could do it from water, but in the water the difference is you still have a hydrogen atom. If you heat it up above 800 degrees, this one disappears. And then you can get this one. And you found it all over this place here. So this is the Mars. But the Mars is not alone. You see, there are some moons. And the moons of the Mars are called Phobos and Deimos. The Mars has 2 moons, not just 1. 2. And actually, we had a mission also to go to the Phobos. Well, unfortunately, it failed. The second stage of the rocket didn't start. But we were really ready to go there and investigate the Phobos. But, you know, so the Mars was once a blue planet, but no more. And why? And one answer can be volcanoes. Volcanoes, maybe you think volcanoes are bad. And if you are close to the volcano, they are. If you're inside the volcano, they are. I've been in Japan in one of the biggest caldera in Kyushu, and I was standing and looking in the volcano, and inside this crater, 70,000 people are living. But yeah, if this volcano has some eruption, it doesn't make me feel good. But volcanoes are dangerous. But these volcanoes, they blow a lot of gas into the atmosphere, increase the pressure, and then liquid water is stable, even on the Mars. But this was lost. Volcano has stopped on Mars, but there was in the past some volcano. And also there was a magnetic field on the Mars, but it has also stopped. And when the sun wind is coming with 400 kilometers per second, the sun has light, which comes at 300,000 kilometers in a second. But the wind is much slower, but it is deviated by the Earth field and creates some lights in the north and in the south. Aurora borealis and australis. But if you have low pressure, then you have no hydrosphere, and then the water was gone. And the same may happen to Earth, and we can think how to avoid this. And that would be very nice. So we had 15 very nice years on the Mars. So 90 days was planned, but we had more than 5,000. The Spirit rover had 2,208, and the Opportunity more than 5,352. And for me, the very spectacular thing was on the 5,000th sol of the Opportunity rover. It was on the 16th of February 2018. I celebrated my 50th birthday, precisely to the day, overlapping with Earth's day, of course. As you know, it cannot be 100%. So I went to the NASA, had a talk, and said, thanks to my mom, because she's responsible, and for the good timing for everyone. So I really enjoyed this very much. So we had more than 45 kilometers, and 45 kilometers, you know, means you are making the distance of a marathon, but on the surface of a different planet. So the NASA awarded us with a medal of a marathon on the Mars. And these are the tracks of the rover. And so this is very nice, because we made it. Maybe somebody else will do it in the future, but so far we have the record. So what mankind has driven on the surface of another planet or any other object in space, we have the longest distance until now, but in the future somebody will drive further like this. Actually, it was very interesting because the record before were made by the Russians on the moon in the 70s. So they were quite good at that time. Yeah, and so we had a very good time, and we could learn a lot and study a lot and get to a lot of information on the Mars. And there are many, many details about this lifespan of these two rovers and the progress of it. And we were afraid. There were dust devils on the Mars. These dust devils, we thought, if they come, they can create lightning. They can melt rocks. They can destroy a rover with a flash. You know, if you are hit by lightning on Earth, it's something you don't want to experience. And on the Mars, we were expecting if they coming, and we saw them coming, you see, these dust devils. But these dust devils, instead of killing the rover, they moved away the dust from the rover, the dust which was on the solar panel, and the solar panel needed light, but with dust there is no light. So they cleaned the rover, so we renamed the dust devils to cleaning events. And you can see what they did. Here, this is the sundial before the cleaning event, and this is after. So we have really improved the lifetime of the rover with these dust devils. Without these dust devils, probably the rover's mission would have not lasted longer than the 90 days, because already the power getting from the solar panels was decaying. And here you see the rover while he was full of dust. And then after the cleaning event. So full of dust, and then after the cleaning event. And if these are all solar panels, and if you have some solar panels at home, then you know here they produce much more energy than there. And this is a selfie made by the rover. And but you see, this selfie, you see this takes quite a while because he had to rotate his camera up here in many ways, and then you have to stitch together the things, so it took quite a lot of work to get this selfie done on the Mars. I mean, if you have nobody to help you, yeah, selfie is great. So there's some breakdance on the Mars. If you know why we did this breakdance, ask me in the question section. So here was the first spectra. This is Gustaf Klinghofer. So he was like the second generation of this device, and I'm now the third generation following him, but he was one of the important persons, so he was my boss at that time. And this is Professor Rudolf Mössbauer in 2011. Unfortunately, he has passed away in 2011. This was in 2003 in Muscat, this picture. And he was happy that this works, because at that time he thought, oh, maybe it doesn't work because it's so sensitive. And at that time we had problems flying to the Mars, but that's a different story. And here I am at the NASA Control Center presentation, NASA, and I present the first spectra of the Opportunity rover. And it was very nice. And we had nice publications on this, and even the Science magazine awarded us with the best result of the whole year. The breakthrough of the year for this finding of the liquid water on the Mars. And here is actually some very important person. He not only received the Nobel Prize in 2007, he was also the vice president under President Clinton, and he signed for the check so that we could get the money for the mission. And he was there, shaking my hand. This is, by the way, my NASA passport. And I had to sign up 10 years of prison if I by chance forget to take this passport to Europe. So I always had to drop it in the US with the NASA. Otherwise, you know, So he shook my hands. I liked this very much, and he was really interested in the science. So at the same time, there was Arnold Schwarzenegger coming with his family at that time, but he had so much security around him, and he did not ask scientific questions. But I'm not going to tell you the details on that. Now, we used also this lovely device for something else. You see a newspaper headline of Hanover, the New Presse. This is actually my brother. He found some artwork in a garage among some garbage. And he said this could be some lost Klimt picture, but some others said, no, this is garbage. So if it's really garbage, so I said, then we can do some science with it. And we found that on the surface, there was some pigment which did not fit to the age of Klimt. Klimt passed away in 1918. This is so much longer time ago. Well, let me show you Klimt. Who is Klimt? Who is Klimt? Who is Gustav Klimt? Klimt did this picture, and with this picture, he became the most expensive painter in the world who has ever been on auction. And he did also this one. This has never been an auction. He's probably much more expensive, but you can see it in Vienna, in the Belvedere. And Gustav Klimt is now among the top 10. Now the most expensive picture is Da Vinci, but Gustav Klimt, or here in Japanese, this one was sold for, I think, 150 millions, but definitely a very valuable painter. And then, so why is such a picture in the garage, or why is it lost? And so we used our device, and we can see different layers, and we saw below this surface there is something below, and we could see these different layers with our machine, and we could say there is something below this, and the layer below is much older than the layer on top. So the top layer was made after the Second World War. It was made from pigments like the white pigments here, some titanium dioxide, and other things, but a completely different chemistry on the surface. And below we found really the typical Klimt chemistry, which he used to use. And then on the wood we even found some signature. Right now we have just finished a PhD thesis on this subject with 600 pages and 200 additional pages, and we are writing a book on this, and there will be also some movie about this, but it will be exciting, I hope. So this is actually, probably I don't have time, so this was from Dreisat, so they made some small clips on TV for these things, but it's only in German, so if we have some time at the end, maybe I can play parts of it, but also the Japanese got interested in these things, so this is some some Japanese journal. We did some measurements in Japan on some synchrotron, and you see, yeah. So obviously this story is of interest worldwide. And actually, with our little device, Hanover, you have to know, is in the north. It's in the north of Germany, and in the history books is written, the Romans have never been to Hanover. They stopped at the Rhine. But we found, on this field, we found many evidence, and we have now published a book even on this. We found a lot of hints, and we did measurements with our lovely device to confirm this. And even so, some archaeologists claim, no, there is no Roman evidence, but now we even have golden coins found and many other artifacts. So it's very difficult for them to tell there is no Roman origin. I mean, I did not steal these coins from anywhere else. And even there is a whole, maybe even some buildings built below the soil. So now the question is whether the government will destroy this area just to use the rocks for building houses, or they save it for the future. And for Hanover, this would mean to have, instead of just 1,000 years of history, an extension to 2,000. And even there was some petition to the parliament, so I was invited in the parliament to give some statement about this work, and I did. and I hope I convinced the politicians, but they decided that we let the people decide who decided that it is not. And I still don't understand, but it's still not decided yet. But as you can see, it's going on for several years. So I have been twice already invited. We'll see what's going on. But this device was very useful even to save this Roman space. And now we come to my big question, which I have asked you. Anybody has an idea which could be the name of the element? Iron. You think it's iron?
Yes, because of the Eiffel Tower.
So it's iron. And you think the artwork is the Eiffel Tower. So who is for iron? Who thinks it is iron? Okay, there are more people than... okay. Who thinks it's the Eiffel Tower? Who has any other idea? No other elements? There are so many lovely elements, but I love iron myself. What's the name of the society if it's the Eiffel Tower and the iron? With more than 100 million people, I mean, you should see, and these are not the Cantonese people. They have more than 100 million. The Japanese could also qualify with 125 millions. Okay. The answer is, you are. Because the element is the iron. This is true. You're all right with the iron. But this artwork is the atomium in Brussels. And this artwork is nothing else than the unit cell of iron at room temperature. So these are the iron atoms in the smallest unit. And this one, multiple times, creates a piece of iron at room temperature. So this is really just iron. And why? Why iron? And the community is the European community, because it was founded just for iron. Why? After the First World War, the Völkerbund did not work. There was a Second World War. And then they decided to have the United Nations. But you see how helpful it is. But in Europe, we decided to have the biggest community to control the resources for making weapons. And without weapons, there is no war. And in this case, no iron, no weapons, no war. And we have the longest peace period in Europe ever because of this. Therefore, we should be very thankful to the European community, which was founded just for controlling the iron and the carbon, which makes steel, which is the major product for creating weapons. And this was the big teaching after these two big wars, and that's why it really worked in Europe. I'm very happy. Unfortunately, there are other people who have other things in mind, as you know well. But this we should never forget. And we are the community. We are the European Union. And it's really for the iron element. And that's why I really like to repeat this, because it's so important. Now, what are our next plans? We want to go to the moon, as I told you. And I hope that we can succeed with this on the Artemis mission, or to the Mars with a helicopter to fly there. Now, here is the former president of my university. And every autumn, he welcomes the students. More than 1,000, they are in front of the president, and he selects some representative from the professors and from other groups of the university to talk to the new students. And in this year, I was allowed to shake hands with some of the fresh students, and I did it this way. So this is me, and this is the student. And the student is just making a nice fly, as you can see. So this is a very warm welcome. But if you think I'm mean, this happened the next year. This is the student, and that is me. So we always exchange the positions. So I teach also this Japanese martial arts, which is like Aikido and Daitoryo Aiki Jutsu. And I teach this at the university. And this symbol means metal, and this is the modification, what kind of metal it is. And after the Second World War, this is the lost metal, which is the name of iron. And before it was the king of the metals. Iron was the king of the metals, but this is the modern writing, I can say. And Franz, my name, Franz in Slovak language means pharaoh, which is iron which has lost 2 electrons. And in Hungarian language, it's feri, which is iron which has lost 3 electrons. So my name is very associated to the iron. That's why I put this name here. And my Japanese sensei calls me Techa. So with this, I want to say thank you to all of you. Thank you very much. This is my dog. Unfortunately, he has passed away, but he was also called Ferro Einstein because he was born in the year 2005 when Einstein had this famous year. And I also called him like this. Yeah, thank you very much. These are the people who contributed to the mission much closer to this device. So you see there are much more people than just me for getting such a device to space. And these are some people of my working group. This is Dagmar, who wrote the book about the Gustaf Klimt work, and her son just got his promotion with the fresh Nobel Prize winner, Professor Zeilinger from Vienna, just the same year. And I'm very happy about this. And I want to say thank you to all of you. Dankeschön. Who has some questions? Yes, please.
Why do you need the sundial?
Ah! Thank you very much.
You need the sundial.
Yes, why do we need a sundial? And actually, this sundial is very important because the sundial, what is the sundial doing on the Mars? This sundial is actually, with the help of the sun, creating a shade. And from this shade we know where is the sun. But when we know where's the sun, we can calculate where's the Earth. And so the rover is using this information to orient its antenna pointing towards Earth, to send the data to the Earth. So we need this from the shade. We can tell you where's the sun and how can we find the Earth from this. Therefore, this sundial is very important. And then the second thing, you have here colors. And these colors we use for calibration of our cameras. To see, we know blue looks now like this. So we have to correct for the dust, because the dust will be like everywhere. And if the blue looks like this, then we know that the correction is much bigger. And so this has more than just one function. It's a calibration target, and we use it really for the orientation of the rover to find Earth. And we can see Earth from Mars, and it's a small spot on the sky. Yeah. Who has another question? Yes, please. Microphone is coming.
Can you tell us more about this spectrometer device, what it's going to do on the moon?
Oh.
And when this mission is going to be?
Yeah. Maybe the next question, you can already raise the hands, and the microphone, then a second microphone can go there. Yes, so what are we going to do on the moon with this device? Well, there are lots of iron minerals which we want to investigate on the moon. And these minerals we want to use. I'm a member of the International Lunar Research Team from European Space Agency, and the aim is to make an international lunar research station. Yeah, this is a big target, and actually to start from the moon towards the Mars. That's the idea. And this is a collaboration, so instead of the ISS having some station on the moon, because yeah, it's not too bad to be on the moon either. You know, to the International Space Station you can fly within 1 day, but to the moon you can fly within 3 days. Why not? So far, the longest trip was with the Apollo mission, was Apollo 17, and they stayed for almost 3 days. And Harrison Schmitt, or Jack Smith, he's he told me he had lots of problems on the surface because the astronauts movability, so there was some dust in the clouds. And it's so nice when you can have direct contact to such people, when they're still around, still available. And I'm just in the process writing a publications with some of these Apollo people, Apollo mission people. Yeah. Okay, so these are one of the things. So next question, please.
Hello, thank you for the nice presentation. I have a question from her.
Yes, please.
About the slide from Pathfinder that's moving like a dance step.
You mean the...
Yeah.
Okay. Okay. So why do we do a breakdance on the Mars?
Yes.
And you see, we were driving like this, and when we have a super drive, then we drove like this, 100 meters a day. Super drive means you really move very slowly on the surface of planet Mars. And still, we use the front wheels, not only for driving, so we turn them and dig some holes to look a little bit below, what is below there. And when you do this, when you use this for driving and each of them has an electric engine, then, you know, there's nobody maintaining. But you have a car. How many times a year you send your car to the workshop to keep it in shape? Maybe one time, maybe more often. Maybe you're lucky 1 year and don't have to pay, but then you pay twice the next year. But on the Mars, there is no workshop. The rover cannot have anyone helping him. So we found out these wheels, the electric engine, got weak. So the resistivity increased, so that means maybe it will break. And if they break, and then it will block the rover. And we found this problem on the Spirит rover. And that's why we wanted to avoid it on the Opportunity rover. And that's why we did the following thing. We changed our position and drove backwards, because then the front wheels are the back wheels and the other way around. So we could drive like this, but we could not see with the camera everything. So we had to do like, okay, everything's okay. Okay. So this is how we had to perform a breakdance, just to keep the lifetime of the wheels much longer. And it worked very well. Also, there was some corrosion, but after 15 years, without any check, this is amazing that it was still working, yeah. Any other questions? If this, yes, please. I was going to say, if this is not the case, then I thank you very much, but...
Hello. First of all, thank you for the presentation. And second of all, for you personally as a scientist, what's your biggest dream, the thing you want to achieve, and to achieve it soon enough, so for you and me to be able to see it in our lifetime? Thank you.
I could not understand the last part. You said my biggest dream.
Your biggest dream, but not in general for science, something you think it's possible to see in your lifetime.
Ooh. You know, at this stage you have to say always peace on earth, because this is always the biggest dream, and we can contribute a lot to this. And I mean it. I started really to work on the development of some very good energy storage system, which is a big alternative to gas and oil, so that Europe can be independent of these things. And this will be not only of benefit for Europe, this will be of benefit for the whole world. And it will really bring peace, and it will bring energy, you know, heat and electricity. So you have one storage in your home, and this storage, you have solar panels on your roof, and it will, the sun in the summer will fill it up, and you can heat and get electricity from it for the whole year. So your house can be almost independent. And this is one of the dreams now I think many people have, and I really work on this with a small Austrian company. And I think we are very close, actually. And at the same time, we want to use this storage for the space mission on the Mars and on the Moon. Because there we also need such kind of storage systems, which are a new alternative, a new future for many things. And I have many dreams, but this is one we all need. And that's why I follow that. And what we have learned from these missions is very important for all of us, in my opinion, because I see many developments for the whole Earth, which we can learn from Mars. Mars is a little bit ahead of the Earth, and now we have a big chance to really take these lessons and change our world to become a better place. Thank you very much. Actually, it's very difficult to have another questions after this, but please.
I wanted to ask about the cleaning events, how often they happen, and if they, for some reason, suddenly stop happening, how can you install some kind of device that would totally clean the Mars rover and, yeah, the panels, the solar panels?
You see, you know what was the solution for these cleaning events? The solution for the NASA was, actually, our rover is like, now the new rover, the Perseverance rover, is the size of a Volkswagen Beetle. And then the solar power is not enough anymore. And these lithium-ion batteries, they don't last as long. The storage I've been just talking about, the hydrogen storage, is like 30 times smaller than lithium-ion battery storage. So much smaller, so you can really use it for these purposes. And, but NASA is using on this rover a battery which is much more dense than any hydrogen storage, which is 1 million times more dense. It's using plutonium. It's a 1 million times higher energy density for 1 kilogram in comparison to the biggest hydrogen storage we have. But the plutonium battery, if it's toxic and it has radiation, so on Earth it is not the best thing. But on the Mars, this rover, this battery can give you power for 1,000 years. So, but it has some other problems, you know. The cost of Fukushima for the first 10 years was 160 billion. And can we afford this? I don't think so. But I don't know what, well, there are many crazy things what mankind is going to do, and we hope to at least avoid some of them. Well, anyway, I hope this was an... So these dust devils, they don't need any cleaning system anymore, and still the dust devils could destroy them. We cannot avoid this, but so far it did not happen. Yeah. So, thank you very much. Dankeschön.